This is the practice for section 5.2. We're going to look at number 2. You have 3 angles given in terms of a variable. Add them together. They must add up to 180. Since it's the same variable, this is pretty easy. 1x, 2x, and 3x give you 6x. So 6x equals 180. That means 1x, when you divide by 6, gives you 30. And you're looking for the value of the variable. So you don't need to plug in, but you could. X is 30. 2 times 30 is 60. 3 times 30 is 90. Did these numbers jive? 30, 60, 90. Do they add up to 180? They do. Number 3 uses variables also. You could use triangle angle sum theorem if you wanted to, or since it's a right triangle, you know these two acute angles must add up to 90. So you can start with that equation. Combine your like terms. Subtract 3 from both sides. Then divide by 3. So 3 goes into 87. Well, 3 goes into 90 30 times. So 3 goes into 87 29 times. Number 5, the 3 missing angles of a triangle are all the same. They would all have to be 60. It's an equilateral triangle if all the angles are the same. So they're all 60. We have a theorem that says that. Number 11, you have an exterior angle of a triangle. It's going to equal the sum of their 2 remote interiors. So you could write this equation. But then you're going to realize I don't know this angle and I don't know this angle, and they're different variables. So this equation doesn't really help you. You do know that's 55 and that's 28. So you could figure out what this missing angle up here is, the one that they're calling 40 plus y. You could figure out what that is right now. So that's what we're going to do. So I'm going to do 180 minus 55 minus, what's the other one, 28. That angle right there is 97 degrees. So now we know what it is. Now we can eliminate this whole y business. We can just put a 97 there. And 97 plus 28 is 125. So we can simplify this thing a whole bunch. We're going to add 7 to both sides. And then we'll divide by 6. How many times does 6 go into 132? "22 times. Number 13. This triangle is isosceles. That's important. This triangle is also isosceles. That's also important. Classifying your triangles is really important. If your vertex angle is 56, your 2 base angles are the same. So you know there's 180 degrees in a triangle. Take away 56. That's going to give you 124 degrees, which you have to split between 2 equal measured angles. So they're both 62. Now on this other triangle, you have a linear pair right here, and that angle that you need to find is actually the vertex angle of that other isosceles triangle. So if that's 62, this guy must be 118 because they have to add up to 180. It makes a line. It's a linear pair right there. So if that's your vertex angle, 118, take that 118 away from 180 and then divide by 2. You get 31. Classifying your triangles helps you there. Last one we'll look at, there are 3 triangles here. You got a 53 and an 80. So let's see what the other angle is going to be. 180 minus 53 minus 80 gives you 47. So this third angle is 47. Now we're going to do the same thing on this triangle. We know a 50 and a 62. So we're going to do 180 minus 50 minus 62. That gives you 68. And that'll be this angle here. Now, finally, don't forget, this is a triangle also. So if you know those two angles, then you should know that angle. So we're going to do 180 minus 47 minus 68. And that's going to give you 65. So that's the measure of that angle. Now, they want you to find x, which is up here, and that seems really, really confusing, but these are vertical angles. So x is 65 as well.